So in this video, we are talking about reciprocal functions. Now, a reciprocal function is basically a curve whose equation has a variable in the denominator. Now, there's something really significant about having one of the variables being on the denominator and having the other as the subject of an equation. So something like this thing you see down here, y equals to k over x. Now, k is just a number. This can take on a whole value, different sort of constants. So k can be 1, it can be 5, it can be 2, it can be -1. But our general reciprocal function, or what we call a hyperbola when we graph it, comes in the form of y equals 1 over x. That's basically the simplest hyperbola. Now, in order to understand a reciprocal function, we want to look at how these two variables interact. That's essentially what we're trying to do every single time when we interpret a function. Now, having x on the denominator here, let's just substitute in a couple of values and just look at what we notice occurring. Now, let's say x was 1. So when x is 1, y equals 1 divided by 1, which just gives you 1. Now, that's clearly that point on our graph. Now, we're going to imagine what's going to happen as x gets bigger. As x gets bigger, the denominator gets bigger, meaning the fraction itself gets smaller. So if x was 2, we would have 1 over 2, which is a half. So the output, the thing we get out in the y, is getting smaller and smaller. If we make it 3, a third is a smaller fraction than a half. When x is 4, a quarter is a smaller fraction than a third. So as x gets bigger, the fraction we get out in y is getting smaller and smaller and smaller and smaller. Now, as x approaches, say, a really large number, say infinity, y is going to approach 0. It's going to get so close to the x-axis, but it will never touch it. Now, a similar thing happens in the negative direction. When x gets bigger in the negative direction, we're still getting a negative fraction, but it's getting in its denominator bigger and bigger and bigger and bigger, meaning the fraction is getting smaller and smaller and smaller and smaller. But as this denominator gets infinitely big, the output, the y, the fraction we get out, is still approaching 0. So what that means is we get an asymptote along this x-axis. So as x gets bigger, y gets smaller. That's one thing we notice. As x gets bigger, y gets smaller. So there's a kind of opposite relationship happening here. Now let's imagine what happens as x gets smaller. Now, say we move to the left of this point, 1, 1. Now imagine we substituted in a half in for x. We started thinking of x in terms of fractions. If I put a half in here, I would get 1 divided by a half, which gives us 2. So that's here. If I put a third in for x, I get 1 divided by a third, which is 3. A quarter, 1 divided by a quarter, which is 4. As this denominator gets smaller as we get to the fractions, the value of y gets bigger, and it gets bigger at a really kind of rapid rate. So we see, again, an opposite relationship happening. As x gets smaller, y gets bigger. So as x gets smaller, y gets bigger. This is the essence of the reciprocal relationship. Having one of them on the denominator and having the other one as the subject of the equation, as this one gets bigger, y is going to get smaller. That's why we see the graph going down like this. And as x gets smaller, y gets bigger. And we see a similar thing happening in this one on the right. However, the negative, like we've seen with negatives in the past for our other functions, it just reflects the graph. So here, this one and this one, we have it in the first quadrant, in the third quadrant. Here, the graph has been reflected. So this one has been reflected down to here. So the first has been reflected into the fourth. The third quadrant has been reflected into the second. But we get that same relationship happening. As x gets bigger, y gets smaller. As x gets smaller, the y output gets bigger. So these are some of these key features that we've kind of summarized. Now, our basic hyperbola has the equation y equals 1 over x. Now, no value exists for y when x equals to 0. That makes sense because we can't divide a number by 0. So if we had 0 on the denominator, this would be undefined. If you put it in your calculator, it will say math error. Now, looking at that, that is why we have this asymptote here, because as x approaches 0, y gets way, 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 way bigger, but it will get closer and closer and closer, but it will never touch this y-axis. That's where we get that second asymptote, because x can never be 0. So this entire section, the graph will not touch. Now, the curve has two parts called branches. So these are what we call our branches. Now, each branch is in the same shape and size, and they're symmetrical and in opposite quadrants. So we can see that here and on the second one as well. Now, the x and y-axis are asymptotes of the curve. So that is the curve approaches the x-axis and the y-axis but never touches them. And the asymptotes are also at right angles to each other. So we also sometimes call the curve a rectangular hyperbola. Well, these are the main kind of features of the graph. Let's just explore a little bit on Desmos like we've done for some of our other functions, just to see the effect of changing this k value. Now, this is the basic hyperbola y equals 1 over x, because my k value is 1. Now, as this increases, we'll notice that our branches get further away from our origin. Now, let's just think why that is. Let's just go back to k being 1. Let's take this point when x is 2, y is a half. Can't really get it on there fully, but you know what I mean. When x is 2, y is 1 over 2. Now, say we stretched out the k value to be 10. What this essentially does is it takes our graph, we still have the asymptotes, it still approaches the x-axis, but it takes longer to get to our asymptote. So we're actually delaying the process. It's stretching it out. And the reason why is, imagine we substituted in 2 again for the x. I would get this time 10 divided by 2, which gives us 5. So we're still getting the asymptote. As x gets bigger, y will eventually get smaller and approach the x-axis. But stretching it out by making this k value bigger, it just takes longer to get to the asymptote. That's why our branches move further away from the origin. And as k gets smaller, they get closer and closer to the origin. As we get to these really small numbers, we get really, really close. And once again, once we get to the negatives, we are now in the other two quadrants. And the more negative this gets, we get the same thing. It stretches out into both directions, but it's just happening in the other two quadrants because the k value is negative. When k is positive, we return to the first and third quadrant. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.